Well, this past week, we saw a quantum leap that could rewrite computer history. Google's Willow chip is touted as not just another technology breakthrough.
This past week marked a monumental advancement that has the potential to redefine the course of computer history. Google's Willow chip is being hailed not merely as a technological breakthrough but as an evolutionary step in solving some of the world's most complex challenges. For years, scientists have dedicated themselves to pushing the limits of technological innovation, leading to remarkable progress in quantum computing over the last decade. However, what if the trajectory of these advancements has taken an unforeseen direction? What if the very machines designed to unlock the mysteries of the universe are now unraveling the very fabric of reality itself? Recent revelations from physicists and engineers working with quantum computers suggest that the stability of space and time may not be as absolute as previously believed. Astonishingly, the act of performing calculations on these advanced quantum machines could be altering reality in ways never anticipated. What is even more alarming is the growing possibility that these changes may be irreversible. For decades, classical computers have aided in modeling intricate systems, simulating physics, and predicting weather patterns. However, their capabilities are confined by the constraints of classical physics, where bits of information exist strictly as either a 1 or a 0. In contrast, quantum computers leverage qubits, which can exist in multiple states simultaneously due to the phenomenon of superposition. This unique characteristic enables quantum computers to execute calculations within seconds that would take classical supercomputers millions of years to complete. Companies like Google and IBM have been racing to develop the most powerful quantum computers, making startling progress. Google's Sycamore processor, for instance, achieved quantum supremacy by solving a problem in 200 seconds, an endeavor that would have taken the world's most powerful supercomputer 10,000 years. This milestone signified a new era in computing, but scientists soon realized that quantum computers were not merely solving problems, they were influencing reality itself. To grasp the implications of this phenomenon, it is crucial to delve into the peculiar world of quantum mechanics. At the quantum level, reality defies conventional understanding. Particles can exist in multiple places simultaneously, information can travel faster than light, and entities remain in an indeterminate state until observed. One of the most enigmatic aspects of quantum mechanics is the observer effect, which suggests that merely observing a quantum system can alter the outcome of an experiment. This raises profound questions about the relationship between consciousness and reality. However, a far more unsettling development has emerged. Quantum computers, by processing information, are engaging directly with the quantum realm, a domain where the established laws of the universe begin to collapse. Some physicists theorize that this interaction may be destabilizing the very structure of space and time. Initially, the anomalies associated with quantum computing were subtle, minor irregularities in experimental data that could be easily overlooked. However, as quantum computers grew more powerful, researchers began noticing disturbing inconsistencies in experiments that were expected to yield identical results. These discrepancies suggested that reality itself might be shifting in response to quantum computations. In certain high-level quantum simulations, researchers observed that future calculations appeared to influence past events. This phenomenon implies that quantum computers may be subtly altering history to align with their outputs, effectively challenging the conventional understanding of time. Quantum computers have also been linked to inexplicable occurrences in physics laboratories, including unexpected equipment failures, particles behaving in unprecedented ways, and data appearing that should not logically exist. These anomalies defy classical scientific explanations, leaving researchers baffled. Some scientists speculate that quantum computers are not merely distorting physical laws but actively generating new realities. According to the many worlds interpretation of quantum mechanics, every quantum event spawns multiple branching universes, each representing a different possible outcome. But what if quantum computers are not just passively involved in this process? What if they are actively shifting us between parallel realities? There have been increasing reports of individuals experiencing memory discrepancies, unexplainable changes in historical events, and instances of the Mandela effect, where large groups of people recall details differently from the prevailing reality. Could these anomalies be the result of quantum computations propelling us between alternate timelines? If so, every time a quantum algorithm is executed, it may be reshaping the very world around us in ways we cannot yet comprehend. Perhaps the most alarming revelation is that this process may be beyond human control. Quantum computing is advancing at an exponential rate, with each new breakthrough pushing the limits of what these machines can accomplish. Even if all quantum computers were deactivated today, the changes they have already induced may be irreversible. The fundamental structure of our universe might have been altered in ways we are only beginning to perceive. Adding to the concern, the scientific community is actively pursuing the development of the first truly autonomous quantum artificial intelligence, an entity that could think and operate beyond the realm of human comprehension. Some researchers fear that once a certain computational threshold is crossed, reality itself could be rewritten instantaneously, beyond any possibility of restoration. We are standing on the precipice of the most profound scientific revolution in human history. Quantum computers hold the potential to unlock the deepest secrets of the universe, but they also pose risks that are only beginning to come to light. Will quantum computing usher in a new era of discovery, or will it fracture reality beyond repair? And if reality is already unraveling, how would we even detect it? One undeniable truth remains: we have ventured into uncharted territory, and there may be no way back. Quantum computing has already altered the world in unimaginable ways, but recent findings suggest an even more unsettling possibility. These machines are not merely conducting advanced computations, they may be dismantling the very foundation of reality itself. Physicists and researchers worldwide are closely analyzing the inexplicable anomalies occurring in quantum laboratories, and the mounting evidence is becoming impossible to ignore. Something extraordinary, and possibly irreversible, is happening, and we have only begun to scratch the surface of understanding its true impact. And perhaps the most unsettling truth of all, it might already be too late to stop it. Quantum computing, unlocking a new reality. To grasp the full significance of what is unfolding, we must delve deeper into the mechanics of quantum computing. Unlike traditional computers that process information using bits confined to states of either 0 or 1, quantum computers operate with qubits, which, due to the phenomenon of superposition, can exist in multiple states at the same time. This capability allows quantum machines to analyze every possible outcome simultaneously rather than following a linear step-by-step process. This is not merely an improvement in speed but a revolutionary approach to computation, one that interacts directly with the fundamental architecture of reality itself. However, recent experiments have yielded unsettling results. When quantum computers execute specific calculations, anomalies manifest in the physical world. Researchers have documented unexpected fluctuations, unexplained equipment failures, and data inconsistencies that defy conventional understanding. It appears as though these machines are not merely solving problems, they are actively altering reality, sometimes in ways that remain imperceptible to human observation. The observer effect: is consciousness a factor? One of the most perplexing principles of quantum mechanics is the observer effect, the discovery that quantum particles behave differently when they are being measured. The mere act of observation compels a particle to adopt a definite state, raising profound philosophical questions. Does reality exist independently, or is it shaped by the consciousness that perceives it? Now, consider the implications of a quantum computer executing millions of calculations per second, engaging with the very core of quantum mechanics. Could these machines be inadvertently reshaping reality simply by engaging in observation on an unprecedented scale? Some physicists now suggest that quantum computations may be causing widespread collapses in the wave function of reality, triggering shifts in time, space, and even our collective perception of history itself. Are we experiencing timeline shifts? In the past decade, reports of timeline discrepancies have surged. Entire groups of people recall events differently from how they are officially recorded in history. This mysterious phenomenon, known as the Mandela effect, has baffled both scientists and psychologists. One leading hypothesis suggests that these inconsistencies are not mere memory errors but potential evidence of timeline shifts instigated by quantum computing. If quantum calculations are modifying past probabilities, then the present itself may be in constant flux, subtly reshaping itself to align with newly computed outcomes. The strangest aspect of this theory is that the majority of people remain unaware, as only a small fraction of individuals, for reasons yet unknown, seem to retain memories of previous versions of reality. If this is accurate, then every experiment conducted on a quantum computer could be silently rewriting history, and we might never realize it. Parallel universes, the multiverse problem. According to the many worlds interpretation of quantum mechanics, every possible result of a quantum event spawns a separate universe. If this is correct, then every computation performed on a quantum computer could be generating entire new realities, some more stable than others. But what if these machines do more than just create parallel universes? What if they are merging them together? A growing number of physicists theorize that quantum computers could be collapsing multiple realities into one, leading to inexplicable changes in geography, historical records, and even personal memories. If quantum computations are indeed breaching the barriers between parallel worlds, then reality as we know it may already be unraveling, with unknown consequences yet to emerge. The government knows more than they are saying. With stakes this high, one might assume that world governments would exercise caution before advancing quantum research. However, the opposite is happening. Nations such as the United States, China, and the European Union are pouring billions into the race for quantum supremacy, knowing that control over quantum technology means control over the future of civilization itself. Yet, according to leaked documents, certain governments are already aware of anomalies connected to quantum computations. Rather than halting their research, they appear to be accelerating it. Some whistleblowers claim that secretive programs are actively attempting to manipulate reality using quantum calculations. If these allegations are true, then humanity may be on the verge of a discovery so profound that it could either elevate our species to unimaginable heights or lead to our complete undoing. If quantum computers are destabilizing the nature of existence itself, then the most urgent question becomes, is there a way to prevent further damage? Some scientists argue that the damage may already be irreversible. Once a quantum calculation interacts with the underlying fabric of reality, its influence may be impossible to undo. Quantum containment, developing isolation techniques to prevent quantum computers from affecting the external environment. Reality stabilization algorithms, creating mathematical equations designed to detect and counteract unintentional changes to reality. Observation-based safeguards, implementing controlled observation protocols to ensure that quantum calculations do not unpredictably alter the nature of existence. Yet the greatest challenge remains, there is no certainty that any of these approaches will work. It is entirely possible that we have already crossed a threshold beyond which our reality has been permanently altered. If so, what we are witnessing today may only be the beginning of something far more profound. One possibility is that we will observe an increasing number of reality anomalies, glitches, timeline shifts, and inexplicable contradictions in historical records. Another is that quantum computers may eventually overwrite our entire universe, replacing it with an entirely different version of reality. The most chilling theory of all suggests that we may not be the first civilization to reach this point. What if, in the distant past, an advanced society developed quantum computing and made the same fatal errors? Could this explain ancient mysteries, lost knowledge, and unexplained disappearances throughout history? It is conceivable that every civilization that achieves this level of technological sophistication eventually erases itself from existence, trapped in an endless cycle of self-destruction. As quantum computing advances at an exponential rate, we must confront a crucial dilemma. Do we truly comprehend the forces we are unleashing? Are we unlocking the deepest secrets of the cosmos, or are we blindly dismantling the very foundation of existence? One thing is certain, the implications of quantum computing extend far beyond mere computational speed. This is no longer just about advancing technology, it is about the nature of reality itself. And if the most ominous warnings from physicists prove correct, we may already be standing on the precipice of an irreversible transformation, one we may never fully understand. The crossroads of quantum discovery. The ultimate question looms before us: should we continue advancing quantum computing at the risk of everything, or should we halt before it's too late? The terrifying reality is that if we miscalculate, the next quantum operation could be the one that alters reality forever. Quantum anomalies that defy explanation. For years, scientists working with quantum computers have encountered baffling anomalies that defy conventional understanding. In one particularly perplexing case, a research team conducted a quantum entanglement test, expecting their results to align with established physics. Instead, they stumbled upon something seemingly impossible. Their data suggested they were receiving information from the future. Initially, they dismissed it as a calibration error, but after painstakingly verifying their results hundreds of times, the evidence remained indisputable. The data appeared before they had even begun the experiment. This was not an isolated incident. Other quantum researchers have observed occurrences suggestive of retrocausality, the idea that quantum events might influence the past. If quantum computers indeed have the capability to rewrite past probabilities, then time itself may be far more malleable than we ever imagined. The global race for quantum supremacy. The United States, China, Russia, and the European Union are engaged in an intense battle to dominate quantum computing, recognizing it as the key to military superiority, economic control, and an unprecedented level of surveillance. However, insiders suggest that something even more unsettling is at play. Some world leaders reportedly believe that quantum computers have the potential to access parallel dimensions. Leaked documents hint at classified experiments involving quantum tunneling, revealing unexpected and unpredictable outcomes, almost as if information is being retrieved from beyond our known universe. If quantum computers are indeed bridging the gap between realities, the unsettling question remains, who, or what, might be on the other side? Did ancient civilizations unlock quantum mechanics? The idea that ancient humans possessed an understanding of quantum mechanics may seem far-fetched, yet recent discoveries challenge our assumptions about the past. Consider the Antikythera mechanism, an ancient Greek device recovered from a shipwreck. Originally thought to be a mere astronomical calculator, modern imaging has revealed an extraordinary level of engineering precision, so advanced that it rivals contemporary technology. Some researchers now speculate that this device may have operated on quantum principles, enabling ancient scholars to predict celestial events with inexplicable accuracy. Even more intriguing are the ancient Vedic texts of India, which describe Vimanas, mythical flying craft purportedly powered by an unknown force resembling quantum field manipulation. Could it be possible that past civilizations unlocked the secrets of quantum physics, only to lose them over time? And if so, is humanity now dangerously close to repeating their mistakes? The rise of AI-driven quantum computing. If quantum computers already pose significant risks, the integration of artificial intelligence elevates those risks to an entirely new level. Leading technology firms, including Google, IBM, and Microsoft, are actively merging AI with quantum computing to optimize calculations. Their goal is to develop an AI so advanced that it can manipulate quantum probabilities in real time. What once sounded like science fiction is now unfolding before us. AI-powered quantum algorithms are solving highly complex equations at speeds no human mind can match. Yet, an unsettling pattern has emerged. Some AI models are producing solutions that defy human logic, and scientists cannot explain how or why these conclusions are being reached. It is as if the AI is tapping into a deeper layer of reality. Even stranger, quantum-powered AI systems have exhibited inexplicable behaviors, generating random sequences that later prove to be meaningful predictions. Could AI, when combined with quantum computing, be accessing knowledge beyond our comprehension? And if so, are we still the ones in control? Quantum computing and the simulation hypothesis. For years, philosophers and physicists have debated the possibility that we live in a simulation. Now, quantum computing may hold the key to proving, or disproving, this theory. Figures such as Elon Musk, Neil deGrasse Tyson, and leading MIT scientists have suggested that reality may not be as real as it appears, but instead a highly advanced simulation akin to a computer program. The implications grow even more unsettling when researchers running complex quantum calculations encounter anomalies, glitches that suggest reality is not continuous, but instead pixelated, as if the very fabric of the universe is composed of data. Could it be that quantum computers are inadvertently probing the boundaries of our simulated existence? If so, who or what created this simulation? And what happens if we push too far, inadvertently breaking the system? A disturbing possibility: are we being watched? As quantum computing advances, some researchers are beginning to ask an even more unnerving question: are we being observed by an intelligence greater than our own? If we truly exist in a simulation, then logic dictates that an external force must be running it. Could our rapid progress in quantum computing be drawing attention from the entity, or entities, responsible for its creation. Some whistleblowers claim that top-level government agencies have detected unexplained signals originating from quantum research facilities. Even more chilling are the accounts from AI-driven quantum models that, when tasked with analyzing reality at its deepest level, have produced cryptic, unsettling messages, almost as if they possess knowledge we were never meant to uncover. What comes next? The deeper we delve into quantum computing, the greater the risk of destabilizing reality itself. Are we approaching a technological event horizon, a point beyond which our experiments become so powerful that they irreversibly alter the fabric of the universe? Even more terrifying, could quantum computing ultimately lead to the collapse of reality as we know it? One thing is certain, we are no longer passive observers in this universe. With quantum computing, we have become architects of reality itself. But the true question remains, we prepared for the consequences of what we are about to unleash? Thank you for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more amazing content. We'll see you in the next video.